talk about section 2.6. We'll start with example 1, which wants us to show that the limit as x approaches 0 of x sine 1 over x equals 0. So we're going to start with the fact that we know that sine functions are in between -1 and 1. Now, to make this look like this, we're going to multiply everything by x. And I guess let me take one step back. If I plug in a 0 here, I get 0. If I plug in a 0 here, I have division by 0. And it's not an indeterminate form, so it's just undefined. And so we can't use just the product rule where we plug it in, multiply it, figure out what it is. So that's why we're doing this approach. Now, we have the thing that we want, and so we're just going to apply the limit as x approaches 0 to all three pieces. If we do it here, we're just plugging in a 0. -0 is really just 0. We don't know what this one is yet. That's what we want to know. And then if we plug in a 0 here, we get 0. Now, because this limit is in between the same number on both sides, we know that it must be 0. So we've proven it. This is called the squeeze theorem. Okay, let's try the second example. We have the limit as h approaches 0, sine 4h for h, and what we're going to do on the, so we try to plug in the 0, sine of 0 is going to give us 0 divided by 0, so it's indeterminate, so that doesn't work out. What we're going to do instead, we're going to note that as theta approaches 0, the limit as theta approaches 0 of sine theta over theta is 1. And so what we're going to do with that, we're going to just multiply the top and the bottom by 4. Let's use a different color. And we get 4 sine 4h over 4h. Now, we can look at this as if we change theta equals 4h, we can say sine theta over theta, 4 right here, limit as theta approaches 0. This goes to 1, and so now we just have 4 times 1, and so overall our limit is 4. If you have additional questions, please come to Math Lab. Until then, calculator.